Okay, so algebraic properties of equality. This is not new. You guys have seen this in Algebra 1. Okay? Make sure you write down exactly what I'm writing down, because if you skip steps, it may get confusing.
Yes, ma'am.
Alright, so we are going to use the letters A, B, and C. We're going to pretend that they're going to be real numbers, but right now we're just using letters. So, addition property. If I have A equals B,
Then it equals C.
that means that I have AB. Sorry, hold on. Okay, so for the addition property, if A equals B, then that means that A plus C is equal to B plus C.
Is that like,
Just look at the properties, okay?
I don't know what it's called, but is that one thing?
Wait, so are the numbers gonna be like A, B?
Oh, we're gonna get to numbers.
Is it like,
Just don't overthink this, okay? Just write it down first. Okay? Subtract the subtraction property. If A equals B,
A minus.
yep, that means A minus C is equal to B minus C. What we're focusing on is that we have the right property.
A equals B.
If A equals B,
A times C equals B times C.
then A times C is equal to B times C.
Hey, she is smart.
Okay?
A equals B.
If A equals B, I'm gonna let Diana teach this lesson.
A divided by C equals B divided by C.
Good.
Oh.
Okay, so substitution. If A equals B,
Okay.
then that means that
B.
A can be substituted for what?
C.
Alright.
If A equals B, then A can be substituted for B in any expression or equation. That means if we can substitute A for B, they can be substituted at any time. Yep.
That's tough.
Alright, now distributive property is A times B plus C. When we distribute, that's when we have a little rainbow, right? The A goes to the B, the A goes to the C. When I have distribution, are we multiplying or dividing?
No, multiply. Yo, he got me confused.
I don't know what you meant.
Why would you just copy him?
I don't know.
I said multiply. We said the same time.
Oh my goodness, then that means that A times B plus A times C. Because that A gets distributed by multiplication to everything inside the parentheses.
Next
I'm
time.
gonna tell Miss Mitchell you said that, 'cause I know she taught you that.
No, he got me confused. It's his fault.
Alright, so now let's look at the reflexive property of equality. I'm gonna write down some hints for you guys. I want you to write this down too.
A.
The reflexive property of equality, I like to think of as the reflection or as the mirror, whichever one makes more sense to you. That means if I have real numbers, so say we have letters of A equals A, because if A equals anything, the reflexive property is going to equal whatever you see back in the mirror, it equals yourself. Is that from outside?
Yes.
What is wrong with you guys today?
Another time?
No, just yelling, what am I?
We still have like,
Alright, we still have a few minutes to see what this
there's
page.
gonna be one tomorrow.
Alright, the segment length, that means if I have segment AB, Chris, are you with me?
Yes, ma'am.
It's equal to segment AB.
So AB equals AB.
Yep, but now reflexive property, what you see is what you get.
That's
It's like looking in the mirror. Your angle measure, if I have the measure of angle A, it's going to equal what? The measure of angle A. Did you say of B?
I feel like this is easier than the first thing we ever did in this class.
I mean, maybe.
I'm still really dumb.
You guys have also been doing a better job of doing your homework, so I know that this stuff probably makes a little bit more sense. Alright, last one before lunch. Symmetric property. This means to either switch or to flip.
Switch. Oh, shit.
Watch your mouth.
I said shit.
Alright, real numbers. If I have A equals B, then B equals A. Because in the symmetric property, they are flipping. They're just flip-flopping. So your segment length, if AB equals CD, then CD equals AB.
Wait, does it matter if the letters are capitalized?
Yes, it does. And then for your angle measure, let's say that we have the measure of angle A is equal to the measure of angle B. Well, with the symmetric property, then that means that the measure of angle B is equal to the measure of angle A. Once you guys have that copy down, you can go to lunch. All right, let's finish this up. All right, your transitive property. I want you to write down the middleman. We talked about the middleman a little bit with the law of syllogism. It's the same concept. You want to get rid of the middleman.
Let me get rid of it.
Yep. So if you have real numbers that we're calling A, B, and C, we're going to say if A equals B and B equals C, can you guys tell what's the middleman here? What letter's in the middle? You guys see that? B is in the middle, so I can cross that out. So my conclusion is what? A equals good.
Why do you have to be a middleman?
Okay? That's the same thing for your segment length. If you had AB is equal to CD, and CD is equal to EF, what gets cut?
CD.
CD. That's my middleman. So now my answer is going to be AB is equal to EF.
What were we talking about earlier?
Oh my God.
Sure, yes, I covered. Sure.
We covered it.
Sure.
Your angle measure is if the measure of angle A is equal to the measure of angle B, and the measure of angle B is equal to the measure of angle C, what's my middleman here? Angle B. So that means that the measure of angle A is equal to the measure of angle C.
Wait, is there always going to be this?
If it's transitive property, you'll be able to tell because it will look like this. If it looks like whatever's in the middle is the same, you can just cancel it out. All right. Let's look at the reflexive property of congruence. What does it look like if we have a congruent symbol? I know it's the same, but what's our symbol?
All the little squiggly lines.
Okay, it's an equal sign with the little squiggly line on top. Good. So that means if I have segment AB, let's see what is congruent to segment AB. The only difference here is that we're putting our little congruent symbol in there. Okay. All right, my angles. Angle A be congruent to angle A. Okay, because we know that reflexive means what you see is what you get. Okay, imagine you're looking in the mirror. Now your symmetric property is going to be the opposite. Okay, that's where we flip it. We flip or we switch. So my segment length is if I have the segment AB is congruent to segment CD, my conclusion, yeah, my conclusion is going to be segment CD is congruent to segment AB. All we did was we just flipped it. Focus, focus, focus. All right, now angle measure, last one. If I have an angle measure A, which is congruent to angle measure B, what's my conclusion going to be for symmetric?
Angle C.
No. Angle B is going to be congruent to
Angle C.
angle A.
Yeah, it's so confusing.
We have to know your properties. Symmetric means we're flipping. We are not going to do the transitive property of congruence because it's the same as what we just did. The only difference is we're putting a congruent sign in the middle. For the sake of time, we're skipping that part. Look at example 1. Example 1 gives us an equation. We have 3x plus 8 is equal to negative 4x minus 34. Okay, what we have to do is we're going to try to get to x, and we're going to give a reason why we have each step.
Oh no.
Okay, so how should we solve this? We can solve it 4 different ways, but I'm going to do whatever you guys want.
That's no.
Okay, that's not an option. Not right now.
Add the common.
I don't have common, or I don't have like terms here because on each side,
Don't you combine like
I can combine like terms. On each side of the equal sign, I have an x and a number and an x and a number. How do I solve this, guys?
Subtract one side.
Okay, well what?
subtract 8.
All right, let's subtract 8. Write this on your paper. When I subtract 8, I'm left with 3x is equal to negative 4x. What's negative 34 minus 8? Negative 34 minus 8.
Negative 34 minus
Type it in if you need to.
negative 42.
Or are you using your phone and not a regular calculator?
Too lazy to go get one.
Go get one. All right, what is my reason here? What did I do from step 1 to step 2?
You subtracted it.
I subtracted, so what property would that be?
Subtract what's it called?
Subtraction. Property of equality.
Yeah, close.
I know like that.
It's called close.
You have to write this out.
Why?
I said so.
That's weird.
And then you
All right, Sam, how can I solve from this step here? What should we move? Okay, how do I move it? Good. So Sam just told us to add 4x to both sides. So that means I'm left with, what's 3x plus 4x? I'm left with 7x equals. All right, Sam, what operation was that? What property was that? What did we do from step 2 to step 3? We did addition. Property of equality.
Why did I put? Oh,
You have to. If we don't do that, I'm kind of wrong.
really?
Yeah, I'm not asking you for a subtraction or addition. I'm asking you to tell me what the property is, and that's the property.
Addition.
All right, Brian, what do I do from here?
Divide.
Divide by 7. So now I'm left with x equals negative 6. All right, what's that property, Brian?
Division of POV.
Addition, property of equality. All right, and sometimes, depending on how you solve it, you may be done here. Is there anything else that I can do here?
No.
No, okay? But the way that I solved it on my paper, I did use up all 5 lines. But it's not that mine was right, yours is wrong. The way that we just did it together, we had 4 lines, that's okay. All right?
You only have 2 lines.
You won't have 2 lines. All right, look at the second one. If we have our second problem, Chris, what's my first step? What do I do?
Distribute.
All right, distribute the what? The
The
what?
negative.
The negative 3. So my negative 3 goes to 8x and it goes to negative 4. So I have 60 equals, what's negative 3 times 8x? Negative 24x, and then what's negative 3 times negative 4?
7, negative 7.
Negative 3 times negative 4.
Oh, shoot.
Are you typing the negative 3 times negative 4?
Oh, sorry.
We should get positive 12. Alright, so Chris, what property was that you just described? Distributive property of equality.
Oh.
Are you guys understanding what we're doing here? Alright, now what?
Subtract 12.
Good. We're going to subtract 12 from each side. So what's 60 minus 12, Diana? Anybody else somewhere else?
48.
48. Why did you guys get calculators earlier? Equals negative 24x. All right, Diana, what property do we just do?
Subtraction property of equality.
Good.
Oh.
Subtract. If she wants to say it out, she can say it out. Not everybody wants a shortcut like you, even though this is a shortcut
Yeah.
by writing POE.
Oh. Come on, phone.
All right, Miguel, what do I do from here? Huh? Yep, divide by what? We're going to divide by, wrote too big. We're going to divide by negative 24. And I am left with negative 2. Why are you forgetting your negative step? All right, so my end, or my step here was division, right? I'm going to write that in there. Division property of equality.
And don't you
All right.
have to, like, simplify and...
Yes, you're the first person to say that. All right, I don't want to leave. Yeah, I don't want to leave my answer like this. I want my x on the left side. So Diana, how do I write my last step?
You said you put x equals negative 2.
Perfect. And what's my reason?
I don't know what to say.
Inverse property.
Now I forgot how to say it. Symmetric. Symmetric property of equality. Good.
That was
Impressive. All right, good job. So that's it for our notes, but I know you're going to complain on your homework, so let's go ahead and turn there first so you can get a major head start. Everyone has this down? All right, look at numbers 1 to 12 on your homework. I'm going to draw my picture.
It's wrong.
All right, so we have this. So this is angle 1, this is angle 2. So this is
Messy.
50 degrees.
No, bueno. Muy better. Blue is way better. Esto no bueno. No bueno.
All right, Chris, look at this figure. Everyone looking at it? I want you to fill it in as I fill it in. Do you guys notice that I have a right angle between that 50-degree angle and angle 1? Brian, are you with me? Okay, you guys notice that? 90 degree, or a right angle adds up to what? 90 degrees. So if they told me that this bottom half was 50 degrees, what's my top half? 40. So I want you guys to write that in. This is 40 degrees.
25.
Okay? Look at this bottom angle here. This creates a right angle too, so what's that gonna be? A right angle equals 50 degrees? What's a right angle? 90 degrees. That whole angle right there is 90 degrees.
So the whole thing is 90 degrees.
In that angle. Angles 1 and 2 are vertical angles, so what's angle 2 gonna be? Vertical angles to number 1. So look at angle 1. What do we write for angle 1? You guys see how 1 and 2 are vertical? They're right across from each other. So if 1 is 40, what's angle 2? 40. This is our vocab, guys. That means that this also creates a right angle. So what's my top part of this angle? 50. It's also vertical to the red 50. And my angle on the top left is going to be what? How'd you get 90? It's a right angle, right? Any questions on that? So you guys need to know, you can fill this all in on your homework because answers 1 through 12, you need that top part. And then you have a proof, which is what we just did. Make sure you have your reasons. That is your homework.